In today's tutorial, we are going to be covering some of the various different methods of detecting clash throughout a kinematic simulation in CATIA version 5. So I've already done a lot of the prep work here for this model. I have a product with 4 very simple parts of an engine, and the kinematic license is already extracted onto my machine. I have my various joints created, so that way I do have motion. And to kind of quickly go over how I want this part to move, I'll show you first how to do this with the simulation with commands. This is all going to pivot around a rotational change. So if I, with my simulate with commands, if I just grab the immediate option and kind of pull this back and forth, you can see how it's rotating around, and that rotation causes my piston and my connecting rod to move. You can probably already see it here on the screen, but on the tail end of this connecting rod, I did on purpose create a little notch that sticks out on the end of my con rod, so that way as it rotates, it will eventually interfere or have solid mass kind of flying through other solid mass here in my product file. So we are going to see how can CATIA detect that. It's very important to, as you're creating these kinematic simulations, figure out, do you have that occurring anywhere? Because if you don't figure out when this is happening, then CATIA doesn't do anything overtly, kind of visually to let you know, like, warning, warning, you have clash occurring. All right, so I'm going to close down this dialog box, and let's start off with our first kind of, I would think, more traditional method of figuring out the interference. So we do have a static interference report that we can go in and create, and I have this here in my DMU Kinematic workbench, and I'm going to click on my static clash button, and then I'm just going to have it to run the type contact and clash, and I want it to, of course, run it through all components that I have on the screen. If I go ahead and click apply to that, I don't have any clash currently. All I have are a couple of contact constraints that are happening. But eventually, as it rotates, it will eventually clash. So I am going to just go ahead and click OK. That will still leave the interference report as something tangible in my specification tree. So you do want to create it and click OK and have it stored in the tree, because now that we have that saved, we can then have the simulation to actually kind of monitor it throughout. So to do our next step in this process, we're going to create a physical simulation based off of this kinematic mechanism. This is pretty easy to do. I always tell my students, think of the simulation as almost like the little cartoon flip books that you made as a child in art class, where you kind of drew a stick figure, and then on the next page you drew that same stick figure, but maybe his arm was at a slightly different location, and then you drew enough of those pictures and then you flipped through them to where it looked like it was moving. So the simulation box first says, what do you want to base it off of? So I'm going to say yes, I want to base it off of mechanism.1. And then from here, it's really just a matter of changing that degree of freedom that you have, in our case, an angular degree of freedom. So it's really just changing the input value and then hitting insert, and then changing it some more and hitting insert, and changing it some more and hitting insert. So you just do that enough times until you've developed this motion that you want the simulation to represent. Now I'm going to keep this one really short and simple. I literally just want to rotate this up a little bit until I see the clash occurring. So the only thing that I'm really going to do here is I'm going to grab my slider bar at the top, and I'm just going to move this over until it rotates up to a full 360 degrees. So I know that somewhere in that motion it's going to end up clashing. And then I'm just going to simply hit insert. And if I want to quickly play through this to see how it works, I can hit rewind. And if you hit play, it's like, oh, it happens way too fast. So just Anytime that this happens, you do have an interpolation step size that if you make it smaller, it actually slows down the relative speed on your screen so you can see it a bit easier. So I'm going to drop this down a bit smaller in size and then play it, and maybe I'll even slow this down a bit more. So right there is where it's going to start to clash. So again, how do I get CATIA to somehow alert me to that fact throughout my simulation? Super simple to do that in our dialog box. Again, in the tree, we have that tangible interference, so we're just telling CATIA as the simulation runs, keep that clash also running. Now, a heads up, anytime you guys are including a clash analysis with emotion, do expect CATIA to slow down, so you better have patience through all of this. But the actual clicking order is pretty straightforward. At the bottom of your dialog box, you're going to click on Edit Analysis, and it's empty. You're going to click on Add, and the only analysis that we have in our dialog to choose from is our clash. So grab that, click OK, and then click OK again. So now inside of the interference portion of this dialog box, it's no longer grayed out, so it will actually allow me to make my selection. Now we have 3 different methods. We have off, on, or stop. Now off is what it's currently set to, which means that CATIA doesn't care if parts are flying through each other. So that's typically what we have already seen, right? Solid model fly through other solid models. If we switch this method to the on option, and again, I'm just going to slow this down in its step size and then play through it. And notice that with the on option, it highlights those respective parts that are clashing. It did highlight them here in the orange as soon as that clash started. Let me rewind back to the beginning and choose the stop option and now hit play. And obviously this is going to stop the simulation dead in its track as soon as it does recognize that that clash is occurring. Another alternative way that we can take a look at our clash throughout our simulation is with buttons that are very similar. In order to show you this, I'm going to switch that interference back to the off mode. And then over to the side, I do have a flyout here with our various clash detections. So again, very similar setup. Clash detection off says that if I were to play through my simulation, there's no overt warning that 2 parts are occupying the same space. If I, in the flyout, switch that to the middle option, which is clash detection on, this will now highlight areas in red where we have the clash condition that actually is occurring. This is slightly different than the previous method because in the previous method it didn't show us where the clash was in red, it just highlighted the parts that were clashing in orange. So this, I think, maybe gets to the area perhaps a little bit more specific. So I kind of follow up with this method after I know that there's a clash using the interference drop down box. Then I come in and use these buttons to figure out exactly where that clash is occurring. So let's take a look at that. Let's turn the clash detection on. And again, I've got a smaller step size here. And then as it plays through, it will get to that spot where it senses the clash and then the area turns red. Again, it's a very small red outline here, but obviously red's going to draw your attention to those areas so you can detect the interference location a bit better. And then if I were to take that back and then show you the third method, again, that's the clash detection stop. So now as I play through, same thing as before, as soon as it gets to the spot where it's going to realize a clash is occurring, it will stop it dead in its tracks, and again it will highlight that clash area in red. There is also one more quick method of figuring out if you have clash occurring. It's a little bit different. This time it's not associated with a simulation that you've created. It's more on the fly. So let me show you this. I'm going to cancel out of my edit simulation dialog box. It did take it back to its original position inside of that simulation, and this time I'm going to head over to the simulation with commands button, you'll notice that inside of the dialog box there's this activate sensor. So if you turn that on, you can now have in the dialog box all of these different parameters to be observed throughout more of an on-the-fly motion. So I'm going to find where it has my interference results .to clash, and so that's going to, by clicking on it, that's just going to say yes, it should be observed throughout the motion. And at this point, all you're going to do is just going to grab the slider bar, and this is with the, let me slide this over, that's with the immediate option. You can either kind of click on this and drag it, or the alternative method is you can click on request, change it to its final value, and then play through it this way. So as I play through it here, I'm going to pause that. It's a little bit too slow for my liking, so I'm going to speed it up here, play it again. So again, it's keeping track of that clash throughout this entire motion. After it completes, down here at the bottom you can click on the graphics, and this is where you can see in the graph it basically just goes from 0 to 1, meaning that it's no clash detected or 1 is clash detected. So you can see that right at about the 75th step within that simulation event is when the clash did start to occur. So that's a slightly different method of detecting clash throughout a motion in kinematics. And I'm going to finish up this video with essentially a cheat, a workaround. A lot of times you might not have a super complicated scenario where you need to set up all these kinematic motions, or maybe you don't have the kinematic license available to you, and you're still wanting to somehow see how this stuff can still move. So let me close out of my dialog boxes, and I'm going to switch actually into the assembly design workbench. So I'm just cleaning up my tree here, minimizing some things, and I'll switch over to assembly design. So the big thing here is that we have a toolbar. Let me move it out so you guys can see. This is called the Move toolbar. And that Move toolbar has two really important buttons that we're going to use for this workaround. One of them is called Manipulation, another one's called Stop Manipulate on Clash. So to show you kind of how this works, if you use the Manipulation button, you can say, I want to move these items, and there's several ways that you can move it. You can move it along these predefined directions or a direction of your choosing. You can move them within these planar faces or a planar face of your choosing. And then the last one down here is where you can rotate items or rotate it with respect to an axis of your choosing. So that's what I'm going to click on here. So I'm going to say I want to rotate, and I'll click on my crankshaft part here. And then specifically I want to rotate it around an axis of my choosing, and I want to select the axis of the natural occurring, basically implicit axis here on the end of it. And then it's really quite simple. You're just going to click and drag, but if you just click and drag by itself, it's not moving the parts together. So in the dialog box, just turn on that with respect to constraints. So this does assume that you have the assembly constraints created, but obviously, as you can see, I'm just making a circle with my mouse here, clicking and dragging. You can see that it does create this simulation kind of on the fly. So again, that's another quick trick if you're wanting to see how things are moving according to their assembly constraints but don't have the kinematic license or kinematic simulation created. And then at the same time, we're just going to go ahead and turn that stop manipulate on clash on. And then now if I kind of do the same thing, this is where you can see, again, it stops at kind of here because it does detect a clash. All right, and these are all of your different methods of trying to determine where you have clash throughout some type of kinematic simulation, either using the options available in the kinematic workbench or using this cheat or workaround here, just using the assembly constraints in the assembly design workbench.